and LPM, liters per minute, and it's going to be again 0 to 100, and we will add a calibration object. And again, we'll leave it 1 to 1. Double check, everything is in green. So now we have a data acquisition board and instruments. Next, we're going to add actuators. So we're going to add actuator 1 and actuator 2. Actuator 1 is a pressure regulator. Actuator 2 is a proportional valve. So we're going to add actuator 1 and add actuator 2. Open up the property window, and the board name for actuator 1, we'll call it, we'll select board 1, and analog output channel 0. And we could put it just in the description here, we could put pressure regulator, just for our own notation. That's all that property is used for. Actuator 2, we're going to select data acquisition board 1. That's the only board right now. You could add other boards though. And analog output channel 1. The description here would be proportional valve. Next, we're going to add 2 switches. Switch 1, which is just a simple on-off valve, and then switch 2, which is actually going to turn on a vacuum pump. So we're just going to call it 1 and add switch 2. You could name it whatever you wanted, but I like the numerical convention best. So switch 1, we're going to wire to data acquisition board 1 and channel 0. You can define an initial switch state. We're going to leave it as off, but you could have it normally on, so when you turn the system on, that it goes to a high state. And for the description, we'll just call it on, off valve. And for switch 2, we'll say that would be to data acquisition board 1, channel 1. And description for that would be vacuum pump. Click OK. And if you go, right now we're in the tree view. Right here it says tree view. So if you go back 1 tab to the manual control form, you can now see that a manual control form is automatically been created. So right now there's 2 switches, the 3 instruments, and the actuators. And you could actually hit go and run your tests manually. So you could actually control your virtual model. That's really what we're creating here is a virtual model. And the tree view is just a graphical representation of it. And when you're in the manual control form, you're just manipulating that object model. And there's just a nice GUI or a graphical user interface for it. So the next step is to create our PIDs. Our PIDs are going to link our instrument to a particular actuator. So in this case, for PID 1_1, we're going to wire instrument 1 to PID to this PID, and then wire actuator 1 to this PID also. And then we'll be able to specify a set point. For instance, for PID 1_1, say we want to set an inlet pressure of 50 psig, we'll define a set point of 50 psig, and the computer will automatically maintain that 50 psig by continuously and automatically looking at instrument 1 and controlling this pressure regulator under all conditions such that it maintains 50 psig. So we'll create PID 1_1, 1_1, and that's just my naming convention, but you could use whatever you wanted. I like it because 1_1 means that it's wired to instrument 1 and actuator 1. Now, we're not going to, in this demonstration, tune the PID, but that'll be for another exercise. But the PID can be tuned by changing the proportional constant, integral constant, and derivative constant. We can also change the threshold value, which is the tolerance, upper and lower tolerance. Now you'll notice within this PID, or within the pneumatic circuit, for this PID, what we want to do is we want to ensure that we're supplying 50 psig to this breathing regulator right here. So I'll use a different color. So what we want to do is we want to ensure that when this PID isn't enabled, that this switch is always on, or this on-off valve. We want to make sure it's always on in order for this PID to be enabled. So we call that switch logic. So for this PID, we want to specify that switch 1 must be true for this PID to be enabled. So you have to click Enter Table, and when it turns green, that means that everything went in properly. So this PID has all green. It has instrument 1, actuator 1, and switch logic 1 must be set to true. Everything is green, so it's okay. Within the PID, you can, within the property form, you can show the plot, and it shows that you can change the set point here, and you can enable the PID, and you can set a set point. Again, we'll talk about that in another exercise. The second PID we're going to add is 3_2. We call it 3_2 because it's instrument 3 and actuator 2. And again, we're going to wire instrument 3 and actuator 2 to this PID. So we're going to add 3_2. And for instrument, it's going to be 3, and the actuator is going to be 2. In terms of the switches, we're going to wire it to. We're going to say that for this one, the switch logic vacuum pump switch 2 must be on in order for this PID to be enabled. Otherwise, it wouldn't make sense. If this were off, then no matter how much we changed this actuator or opened up this proportional valve, if the vacuum pump is off, there would be no change in flow. So we're going to say switch 2 must be true. Click Enter Table, and that's all there is to that. And we go back to the manual control form, and now there's 2 PIDs. So that's really it for construction of an object model, or this part of it, the hardware portion of it. In the next video, we're going to discuss adding test sequences or tasks